Hi students, have a nice day. In this section we are going to discuss about a new chapter, Thermodynamics. Thermodynamics is a branch of science. The term thermodynamics is taken from two Greek words, thermo and dynamics. Thermo means heat. Dynamic means flow. So what is thermodynamics? Thermodynamics is flow of heat. As you know that the energy stored in a molecule is released as heat when reactions takes place. Okay? So when reaction takes place, the energy stored in a molecule is released as heat energy. So in thermodynamics, we study the interconversion of heat energy and various forms. For example, heat energy is converted into chemical energy. Chemical energy is converted into heat energy. Heat energy is converted into work. Okay, so internal energy conversion. So many conversions we discuss in this chapter. So thermodynamics is a branch of science which deals with the interconversion of heat energy. Okay, so this in this chapter we come across zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics, and many other important terms, concepts. Okay, like internal energy, enthalpy, entropy, Gibbs energy, etc. So before discussing the thermodynamic laws, we must understand some basic concepts such as systems, surroundings, different process, etc. Okay, first of all, we discuss about the system and a surrounding. A system is the part of universe which under observation or which under investigations. So what is system? A system is a part of universe and which is under observation. The part is under observation. Okay, then the other part of the universe is known as surroundings. The other part of the universe is known as surrounding. Okay, so let's discuss some examples. It is taken from two Greek words, thermo. Thermo means heat, and dynamic, which means flow. Okay, the first important point is system. What is system? System is the part of the universe which under observation, which under investigation. Okay, let's take a beaker. In that beaker we conducted an experiment, a reaction. Suppose A plus B, the reactants A and B are reacted in a beaker, and we are investigating only this beaker. Okay, we are observing the reactions inside the beaker. So beaker is a system. Okay, so beaker is a system. Are you clear? Yes. The other part of the universe is known as surrounding. Okay, the other part than the system of the universe is called surroundings. And it is described the properties of a surrounding is difficult because the other part is a large portion. So we are considering the neighborhood of this system. Okay. The other part of the universe is a very vast area. Suppose we have conducted one experiment in the laboratory. the beaker only the system. The other part of the universe, sky, then other continents, okay, like America, Russia, France, all these countries are surroundings. And to describe the properties of surrounding is difficult. So we consider the neighborhood area is surrounding. For example, when we conduct one reaction in a laboratory, in a beaker, the beaker is system and that laboratory room is surrounding. Are you clear? Yes, the beaker is system and the room, the laboratory room or that room is considered as the surrounding. The neighborhood is treated as surrounding. Okay, so surrounding is the other part of the universe. Surroundings. Okay, so suppose this area is taken as surroundings. And remember that the universe is system plus surrounding. And surrounding is shortly written as SURR. Okay, you write full surrounding. So here I write surrounding is system, sometimes syst. Okay, so system plus sur is the universe. Okay, system plus surrounding is considered as the total universe. Are you clear? Yes. And the system and the surrounding is separated by a wall. Okay, here the wall of the beaker is separate the system and the surrounding, and that is called the boundary. Okay, boundary. So what is boundary? The system and the surrounding is separated by a wall. Okay, and sometimes the separation is an imaginary separation. For example, if an explosion takes place in the air, okay, if an explosion takes place in the air, the separation, the boundary is imaginary. Okay, and another example, the border between Pakistan and India. In the land, it is a real boundary, but in the air, it is an imaginary boundary. I think you heard about air boundary. Okay, so when the aircraft crossing the air boundary, the information is given into the pilot. Okay, a warning is given into the pilot. So that boundary is an imaginary boundary. Air boundary is an imaginary boundary. Okay, so boundary may be real or imaginary. In the case of chemical reaction is conducted in the beaker, test tubes or any other vessels, the wall of the vessel is a boundary and it is quite real. In other cases, reactions in the open air, the boundary is imaginary. So you must learn system, surroundings, boundary. Okay, system is the part of the universe which under observation. Surrounding is the other part of the universe than the system. And the system and the surrounding is separated by a wall and is called a boundary. Boundary may be real or imaginary. Okay, and let's discuss the different types of systems. Another important term is different types of system. We have three different systems. One is open system. A second is closed system. Third one is isolated system. Okay, so different systems are there: open system, closed system, and isolated system. Okay, let's discuss one by one. First one is open system. Okay, open system. In open system, energy as well as matter exchange between the system and the surrounding. Okay, energy as well as matter exchange between the system and the surrounding. Okay, let's take one example. When we take a hot cup of tea, okay, when we take a hot cup of tea, a cup of tea is taken and is kept in somewhere. What happens? The water evaporates. Okay, evaporation takes place. The water vapor evaporates. So matter is exchange between the system and the surrounding. Here is a imaginary boundary. Okay, this is a real boundary. So when we kept hot water or hot tea in an open vessel, the water vaporizes. Okay, water molecule vaporizes. So matter exchange. After some time, what happens? The temperature of the tea or hot water become normal. Okay, normal temperature. So what happens? Heat is exchanged. So energy as well as matter exchange between a system and the surrounding. The system is called open system. Another one examples. When we keep ice cubes in the open vessel. Okay, some ice cubes we kept in a beaker. What happens? Ice cubes vaporizes. Okay, from the surface of ice, water escape or vaporizes. At the same time, temperature is flow from, heat is flow from surrounding into the system. Okay, surrounding into the system. When we take hot water or hot tea, heat energy flow from system to surrounding. When we take ice cubes, okay, or ice water, the heat energy flow from surrounding into the system. So exchange is between the system and the surrounding, either from system to surrounding or from surrounding into the system. Okay, that is called open system. Okay, these are very important things. When in future reference, many questions is asking. Okay, then second one is a closed system. Closed system. So here, energy is exchange, not matter. A closed system defines a system which exchange energy between the system and the surrounding, not the matter. Okay, do you heard about closed system? Okay, I take one example. When we keep hot water or hot tea in a closed container which is made up of copper or steel. Okay, so when we keep the hot water or tea in a steel vessel or copper vessel, what happens? Matter doesn't exist between the system and the surrounding. Okay, matter doesn't exchange between the system and surrounding because water vaporizes and condenses and it is again collected in that vessel. But after some time, what happens? The temperature of the system is reduces. How? This wall, okay, this wall conduct the heat energy. Okay, it's a conductor of heat copper, steel, or iron vessel, aluminum pots, they conduct the heat energy. So, temperature of the system decreases. That means the system doesn't exchange the matter. The exchange takes place in energy. So, closed system is the system exchange energy, not matter. Okay, the system exchange energy, not matter, and such systems are called closed system. Okay, and the next is isolated system. Okay, isolated system. I think you heard about isolated wards. Okay, in hospital there are isolated wards. What do you mean by this isolated wards? Okay, and visitors are not allowed. So here in isolated system, neither energy nor matter exchange between the system and the surrounding. Okay, neither energy nor matter exchange between the system and surrounding. Okay, let's take a hot water or tea in a thermo flask. In a closed thermos flask. Okay, thermos flask. What happened? Neither matter nor heat energy. Okay, so in a isolated system, neither matter nor energy exchange between the system and the surrounding. If the system is perfectly insulated, there is no exchange between the heat and matter or matter and energy. Okay, the tea is hot after when we open letter even at a day. Okay, after one completing a day, the tea is in hot condition. That means the flask, the thermo flask is a perfect isolated system. If any complaints, any leakages, the hot tea is cooled. Okay, it becomes normal water. Hot water or hot teas become normal after several hours. Okay, otherwise it is hot. So that's about the different systems. Are you clear? Yes. The next we consider microscopic system and a macroscopic system. Okay, bulk system. Macro means bulk. In microscopic system, large number of particles, large number of molecules we consider. Okay, for example, 1 mole of water. 1 mole of, sorry, this is isolated. I didn't write it. In isolated system, there is no exchange between the matter and the energy. Next is a macroscopic system. Macroscopic system. It is also known as bulk system. Macroscopic system. Giant system. Okay, giant molecules, giant system. So large number of molecules or particles present in the system, it is called a macroscopic system. Okay, and next is microscopic system. Microscopic system. For example, 1 molecule of water. Okay, 1 molecule of water. It is a microscopic system. It is difficult to study 1 molecule of water. The properties of 1 molecule of water is difficult to study. Okay, so in thermodynamics, we mostly deal with the bulk system or macroscopic system. Okay, you remember that. Next is state and state variable of the system. The condition of a system describes in terms of measurable properties like temperature, pressure, volume, etc. is called the state of the system. Okay, the condition of a system is described in terms of measurable properties like temperature, pressure, volume, etc. is called the state of the system. And the microscopic properties are required to describe the system. The state of the system is called the state variables. The macroscopic properties required to describe the state of the system is called the state variables. Example, temperature, pressure, or volume. Okay, so state variables. State variables. Temperature, pressure, volume, etc. Next is a state function. A state function is a property of the system, depends only the state of the system and independent of path of the system. Okay, it depends upon the state of the system. The property state of the system. A state function is the property of a system whose value depends upon the state of the system and is independent of the path in which the system reached. Okay, the path in which the system reached. For example, temperature is a state function. First, initial temperature we consider as 50 degrees Celsius. Okay, 50 degrees Celsius. And the final temperature T2 is 100 degrees Celsius. And the change in the temperature delta T depends upon the initial and final. Okay, initial and final. The change is 50 degrees Celsius. It doesn't depend the path in which the system reached. You can attain the temperature, increasing the temperature by using gases or wood, or you can keep it in a sunshine. Okay, so the path is not depends. Okay, the path is independent. Such a such a functions are called state function. Okay, such functions are called a state function. For example, temperature, pressure, volume, density, internal energy, entropy, etc. are state function. Remember that it depends upon the initial and final state. That is the state of the system, independent of the path in which the system reached. Okay, and examples are temperature, pressure, volume, density, enthalpy, entropy, etc. Okay, Gibbs energy. These are state functions. Okay, it depends only the state of the system. Very important concept. That's why I am repeating. Okay. The next is a path function. The property of a system doesn't depend the state. Not doesn't depends, it depends the path of the process. Okay, it depends the path in which it follows. For example, work and heat. Work is a path function, not a state function. Okay, work is a path function, not a state function. For example, when we are at the third floor, okay, this is a ground floor. Are you clear? Yes. When we are at the third floor, in my hand, one stone is there. Okay, one stone is there. And I throw it into the ground. So simply throw it to the ground. Now the stone is here. My work is just to throw the stone. But another method is there. What is? And I step down. Okay. And go and place there. The work is same. Is the work is same? No. The work is different. I just throw the stone and only a small amount of energy is required. Okay, the work is very small. The stone reaches in the ground floor. And another path is, okay, another path to reach the stone in the place, I back into the ground floor and go there, place it. So work is different. And another example, okay, these are the two places. These are the two places. When we displace one object to the point A to B, okay, or we walk from A to B, is the first path. And we travel in another way. This is the second path. The work is not same. Okay, we travel more distance, more work we done. And this one is path 3. Okay, path 3. Work is different. So in the first path, the work is small. In the second path, the work is more. Okay, less work, more work. And this work is intermediate between the first path and second paths. Are you clear? So work done is the path function. Okay, it not only depends upon the state, but also depends the path of the system reached. Yes, next we discuss a small topic, extensive property and intensive property. Okay, extensive property means the property which depends the quantity of the substance or the amount of the substance. For example, mass, volume, heat capacity, entropy, okay, etc. are extensive property. Extensive property. Okay, extensive properties. So extensive property depends the quantity of the substance, amount of the substance. Example, mass, volume, heat capacity, entropy, etc. Okay, and next is intensive property. Intensive properties. Intensive property means, not intensity, intensive property means the property independent of amount of substance. Okay, the property which independent of the amount or quantity of substance is called intensive property. For example, temperature, pressure, density, boiling point, melting point, okay, refractive indices. All these properties are intensive property. Why? It doesn't depend upon the quantity of quantity of matter or substance. For example, water, the boiling point of water, 100 degrees Celsius. Okay, if you take 1 liter water or 20 liter of water, when the temperature reaches 100 degree, the water boils, even it is in a 1 liter or 20 liter of water. So that means the property which is independent of quantity or amount of substance. Okay, that's about the extensive property and intensive property. One shortcut, one short information. Extensive property is dependent. So ED. Intensive property is independent. So we have remember that ED, II. Okay, ED. Next you can write II. ED means extensive property dependent, I means intensity property independent. Next we have to discuss a different process. Okay, different process in the thermodynamics. So in the next section we will discuss the different process. Thank you.